Section 3.4, example 2, determining whether composition of functions is commutative. So do we end up with the exact same function all the time? Using the functions provided, find f of g of x and g of f of x. Determine whether the composition of functions is commutative. So from here, let's start with labeling it the way it should be. We have f of g of x. That's what this one is. So we'll see it f of g of x. And this here, we have our outside function f of x. So starting out with f of x, f of g of x. What we're doing here is we're inputting one function in for another one. So we could think of it as the function f of x taking in the function g of x. So here we're going to grab this and input it here. G of x is our function 3 minus our input. And from here, f of x, let's write down what f of x is. F of x tells us to double our input and then add 1. So here our input just so happens to be this other function, 3 minus x. And from here, let's just simplify. We could distribute that 2 through both of those terms. 2 times 3 is 6. 2 times negative x is going to be a negative 2x. And lastly, we can't forget that part. We're going to add 1 to it and see what we get. From here, let's combine like terms and put it in standard form. So standard form would just be starting with our highest degree of our variable. Here, I only see our variable 1, so we have negative 2x. And adding the other two parts, so 6 plus 1 gives us 7, plus 7. So here we have f of g of x equal to negative 2x plus 7. Now that we have that, we could find the counterpart, g of f of x, g of f of x. Actually stated the way you'll normally see it, g of f of x. And here we start with our outside function. This time is going to be g of x, g of f of x. We have our function, our outside function g of x is taking in f of x, which we have this here for f of x, 2x plus 1. And now looking at our function g of x, it's telling us to start with 3 and subtract our input. So equals 3 minus our input. And at this point, our input is our 2x plus 1. And from here, we're going to simplify and combine like terms, put it in standard form. So here we have a negative being multiplied to everything inside of those parentheses. So starting off with that negative 3, then we have negative 1 times 2x, negative 2x. And we have that negative 1 times positive 1. It's going to be a negative 1. And combine like terms, put it in standard form. We have that negative 2x and 3 minus 1 is 2. So negative 2x plus 2. So here we could say that g of f of x is equal to negative 2x plus 2. Since we have two completely different solutions here, we cannot say that composition of functions is commutative. So it's not commutative. And because of that, we would say no. And that's it. If you have any questions, please feel free to ask. Otherwise, bye.